Imagine waking in the middle of the night, unable to breathe. There is no smoke, no fire, no attacker, nothing you can see, hear, or smell. Around you, people are collapsing. Animals are falling where they stand. Within moments, you lose consciousness. By sunrise, entire villages are silent. This is not a legend or a scene from a horror film. It happened on the night of August 21st, 1986, beside a peaceful lake in northwestern Cameroon. The lake was called Nyos, and in a matter of hours, it killed 1,746 people. Lake Nyos lies inside an old volcanic crater, surrounded by green hills, farmland, and small villages. Before 1986, it did not appear especially dangerous. Local families lived near its shores, grew crops in the fertile volcanic soil, and raised cattle in the surrounding valleys. The lake was quiet. There were no rivers of lava, clouds of ash, or obvious signs of an approaching eruption. But beneath its calm surface, Lake Nyos had been storing an enormous quantity of invisible gas. Deep below the region, volcanic activity released carbon dioxide through cracks in the earth. The gas entered the bottom of the lake and dissolved into its water. Normally, gas entering a lake can gradually reach the surface and escape into the atmosphere. Lake Nyos, however, was unusually deep, more than 200 meters, and its waters were strongly layered. The deep water did not regularly mix with the water near the surface. Under the immense pressure at the bottom, carbon dioxide remained dissolved, much like the gas sealed inside a bottle of fizzy drink. Year after year, more carbon dioxide accumulated. The surface remained peaceful, while the deepest water became increasingly saturated. Then, on August 21st, 1986, the system suddenly failed. Scientists still do not know exactly what initiated the event. A landslide may have disturbed the water. A change in temperature, heavy rainfall, or a small movement beneath the lake might have played a role. It is also possible that the gas-rich water had simply reached an unstable state and required no major external trigger. Whatever started it, deep water began rising toward the surface. As it rose, the pressure around it decreased. The dissolved carbon dioxide began forming bubbles. Those bubbles made the water more buoyant, causing it to rise even faster. More water rose. More gas escaped. More bubbles formed. Within a short time, the process became a self-sustaining chain reaction, similar to opening a shaken bottle, but on the scale of an entire lake. An immense quantity of carbon dioxide erupted from the water. Evidence found after the disaster suggested that the disturbance produced a violent column of water and foam and generated a wave that struck part of the shoreline. Iron-rich water from the depths reached the surface and reacted with the air, changing the lake's normally blue appearance to a reddish-brown color. But the water was not the greatest danger. The real killer was moving beyond the lake. Carbon dioxide is colorless and normally odorless. It is also denser than ordinary air. Instead of quickly rising and dispersing, the concentrated gas flowed over the edge of the crater and traveled downhill. It followed the surrounding valleys like an invisible flood. The cloud reached nearby communities, including Nyos, Cha, Kam, and Subum. People had almost no warning. Many were already asleep. At extremely high concentrations, carbon dioxide can cause confusion, unconsciousness, and death within minutes. It prevents the body from exchanging gases normally and produces a rapid, lethal rise in carbon dioxide within the blood. Victims could not see what was approaching. They could not escape something they did not know was there. Some people collapsed inside their homes. Others fell on paths or beside doorways. Cattle, birds, and other animals were found dead throughout the affected valleys. The gas traveled for more than 20 kilometers through some low-lying areas before becoming sufficiently diluted. When survivors regained consciousness, they encountered a scene that seemed impossible. Homes were still standing. There were no burn marks, collapsed buildings, or signs of widespread violence. Meals and belongings remained where they had been left. But people and animals lay motionless across the landscape. One of the strangest features of the disaster was its uneven effect. Carbon dioxide concentrated in valleys and depressions, while some people on higher ground survived. In certain locations, a difference in elevation could mean the difference between life and death. Some survivors had remained unconscious for many hours. Others were found weak, confused, or suffering from injuries caused when they collapsed. Medical investigators examined hundreds of survivors and concluded that the symptoms were consistent with exposure to an asphyxiant gas. In total, 1,746 people died. Thousands of cattle and other livestock were also killed, devastating families that depended on them for food and income. At least 845 survivors required medical attention. At first, the cause was not obvious. Some people suspected a sudden epidemic, a chemical attack, or poisonous volcanic gases such as sulfur compounds. International scientists traveled to Cameroon to investigate the lake, examine the victims, and collect samples. The evidence increasingly pointed toward carbon dioxide. There was also an unsettling precedent. Just 2 years earlier, in August 1984, another lake in Cameroon, Lake Nyos, had released carbon dioxide and killed 37 people. Several victims had been traveling along a road near the lake when the gas collected in a low-lying area. The Lake Nyos event had been poorly understood. After Nyos, scientists realized that both disasters were examples of the same rare phenomenon, now commonly called a limnic eruption. Only a small number of lakes are considered capable of producing such an event. A lake must be deep enough to hold large quantities of dissolved gas. It must remain strongly layered, and it must have a continuing source of gas beneath it. Lake Nyos met all of those conditions. Even after the 1986 disaster, carbon dioxide continued entering the lake. The threat had not disappeared. Unless something changed, the lake could gradually recharge and potentially release another deadly cloud. Scientists and engineers therefore developed a method to remove the gas in a controlled way. They installed a long pipe extending from the surface into the gas-rich deep water. Once water was pumped upward and carbon dioxide began forming bubbles inside the pipe, the rising bubbles pulled more water behind them. The system then continued largely by itself, producing a fountain at the surface while allowing carbon dioxide to escape gradually into the open air. A permanent degassing pipe began operating at Lake Nyos in 2001. 2 additional pipes were installed in 2011 to accelerate the removal of gas. Monitoring has shown that the forced degassing removed most of the carbon dioxide stored in the deepest layer, greatly reducing the immediate danger. The system transformed Lake Nyos from an accumulating natural trap into one that could be carefully managed. However, the lake still requires observation. Carbon dioxide continues to enter its waters from below, and questions have also been raised about the stability of the natural dam forming part of the lake's edge. The disaster changed how scientists understand volcanic lakes. It demonstrated that a volcano does not need to erupt lava or ash to kill on a massive scale. Sometimes the danger can remain hidden underwater for decades. Today, Lake Nyos once again appears peaceful. Green hills surround its dark water, and the surface gives little indication of what happened there. But on August 21, 1986, an invisible force rose from its depths and moved silently through the valleys. There was no explosion that could be heard across a nation. No wall of fire appeared on the horizon. No storm announced its arrival. A lake simply released the gas it had been storing. And before morning, 1,746 people were dead. The tragedy of Lake Nyos remains one of the strangest natural disasters ever documented. And perhaps its most disturbing lesson is this: sometimes the most dangerous place is the one that looks completely calm.